Good day, everyone. In this video, I just want to do a quick example computation of a convolution integral. So to begin, we're going to recall that the convolution of two functions, let's call them f of t, and we want to convolve that with, say, some other function g of t. So here's the definition. To convolve these two functions, we have to evaluate this integral from minus infinity up to infinity. It's going to be f of tau g of t minus tau d tau. And so we notice that when we do this, we're going to end up, because we're integrating with respect to tau, we're going to end up with some function of t, which is the convolution of these two functions. Now for the example I want to do, I'm going to define a function which is a pulse. So it's a pulse, and we'll call it p of t, which we will define in terms of the unit step function. It's going to be u of t minus u of t minus 1. And what we'd like to do is convolve that pulse with itself. And we're going to show, the result's going to be something pretty fundamental in engineering, and that is that if you convolve two pulses, you end up with a triangle. All right, now when you're doing convolution in one of the functions, it has a piecewise definition like this. And what we mean is Cp of t is equal to, here we have its terms of unit step function, it's just 1 when t is between 0 and 1. And it is 0 otherwise. So when you have a piecewise definition for one of your functions, or both, and you're going to do convolutions, you generally have to draw a picture. So what we're going to look at is p of t convolved with itself. We'll write like this. It's the integral of p of tau times p of t minus tau d tau from minus infinity to infinity. And both these functions only take on the value of either 0 or 1. So let's take a closer look at what this p of t minus tau is. What you're doing is you're taking the product of these two functions and then computing the area under that product. But notice what we could do with p of t minus tau. I'm going to rewrite that as p of minus tau plus t, which I can write as p of minus tau minus t. Okay, so now if we let t equal to 0 just for one moment, what we're looking at is p of minus tau. And so all that is, that's our original pulse just flipped or reflected about the y-axis. So p of minus tau would look like this. The pulse would go this way. Okay, and this would be minus 1. Now, if you have this function here and this minus t here, there you're sliding it to the right. So if I have p of minus tau minus 1, for example, it's going to be this shifted to the right by 1, and it will look like this. P of minus tau minus 1, just take this and shift it to the right by 1, which means it's going to look like, well, interesting, it's going to look like our original pulse. Okay, so let's see what the product of these two look like. So for the first case, when t is equal to 0, here's p of minus tau, here's p of tau, and there's no overlap. In fact, if t is negative, this p of minus tau is going to be over here, and there's no overlap. We're not going to get any overlap or any non-zero integrand until t is greater than 0. So it's going to become the integral, and in fact, when t is between 0 and 1, we can see how this pulse is going to behave. When t is between 0 and 1, when it's 0, the leading edge of the pulse is here, when it's 1, it's here. So the shaded region that we want to integrate on is going to be between 0 and t. And the height is going to be 1 d tau. So the result of my convolution just for t between 0 and 1 will be equal to this, which is t. We're not finished. That's just what your answer is between 0 and 1. Now next, notice what happens when t is greater than 1. Okay, when t is greater than 1, there's no overlap here. The region that you want to integrate is going to be, here's the leading edge of the pulse, and 1 unit behind, you're at t minus 1. And the region we need to integrate, the overlap, is going to go from t minus 1 to 1. So as long as t is between 1, but not greater than 2, because if it gets greater than 2, your pulse is going to be out here, and there'll be no overlap. So for t between 1 and 2, the integral becomes from 1 to 2, from t minus 1, it's better, up to 1. 1 d tau, and this integral is 1 minus t minus 1, which is 2 minus t. Okay, so we just about finished this problem. Where t is between 1 and 2, the answer is 2 minus t. Now, if t is greater than 2, like we showed, the pulse is out here, and the convolution will be 0. So now let's go back and write our final answer. So it's going to be t, all right, the convolution is going to be t for t between 0 and 1, our answer, and it's going to be 2 minus t, and t is between 1 and 2. And it's going to be 0 everywhere else. So if we look at this, between 0 and 1, here's 1, it's t. Okay? But between 1 and 2, it's going to be 2, got an intercept of 2, so it's going to be up here, minus t, and it will look like that. So there's our triangle. Now, finally, and it will have a height of 1. That is the answer. That is P of t convolved with P of t. Now, I'd like to conclude by just expressing this in terms of unit step functions. Okay, so I see that it's t between 0 and 1, so I'm going to write that the answer is equal to t times u of t. Okay, but then when t is greater than 1, I want my answer to be 2 minus t. So I'm going to put right here with t minus 1. This will turn on when t is greater than 1, and I want to add something here to where the sum of these two things will add up to 2 minus t. So I'm going to take t plus whatever we're supposed to put here, question mark, is equal to 2 minus t. Well, I'll just subtract t from both sides, and it's going to be 2 minus 2t, or 2 times 1 minus t. So this is going to be plus 2 times 1 minus t. Okay, so this is good, this is good, but now when t is greater than 2, I want my answer to be 0. So I'm going to put plus something here, and u of t minus 2. Got to put something here where all of this adds up to 0. So question mark, well, goes right here. So I got this question mark plus t plus this 2 minus 2t. So what do I add here so they all add up to 0? So we want to make this 0. Let's see. I've got t plus 2 plus, so it's going to be 2 minus t. Now I need, what do I add to that to make it equal to 0? T minus 2. This should be t minus 2. So plus t minus 2. That is the description of our triangle right there. That's the description of our triangle using unit step functions. Okay, so that's the conclusion. We showed that when convolving functions that have a piecewise definition, you generally have to draw pictures. Thank you.